Okay, at homework 3C, question 1, we're going to compare treasury bonds with corporate bonds. And we're going to start off by assuming that the default risk, illiquidity risk, and tax exemptions are identical for treasury bonds and corporate bonds. So if these pieces of paper that are issued by a government are identical in all aspects to paper issued by a really large corporation, then they're going to end up having the same price and the same demand curve. If they're identical with respect to default, liquidity, tax status, then they'll end up having the same prices. But then later on in the problem, we're going to introduce the risk structure, like, for example, default risk. Okay, so I'm going to open up my Desmos calculator and set my range. I think we'll set X at 100 for now, and set Y at 100, and see if that works. We can always fix it later. Okay, so the first thing I'm going to do is I'm going to copy in. I'm going to not include the T. I'm going to copy in my supply curve for treasury bonds and my demand curve for treasury bonds. And I want to make them black, so they match what we're doing in the, there's a demand curve, and there's a supply curve. But if I keep doing this, I get both of them black. And then I get a red one. So I want two red ones. And then I can delete this, and I'm ready to go on the next set. Okay, so this is the demand for bonds. And we have the supply for bonds. Okay. The equilibrium price is $8.51. It'd be nice if I could. So the price is 851.528. The quantity of bonds is 605.66. And because everything's identical with respect to default risk or liquidity, the equilibrium is at the same point. Demand and supply match. Okay. We'll go ahead and label the diagram, and I'm only going to label one of them. I'm only going to label one of them because if you label one, you label the other. So there's our equilibrium point. There's our supply. There's our demand. This is our quantity. And this is our price. And the quantity is about 600 or 605.66. And the price is about $851. Okay, so that's how you'd label the treasury, and then you'd write treasury up here. Okay, that's good. Then I'll close, and we'll move on. Now down here is the same exact graph, except we'd write corporate right here. Okay. So at the treasury bonds equilibrium, the price is that at the corporate bonds equilibrium, the price is the same. Because the equations are identical, right? That equation is that equation, right? Because they're identical. It'd be like if government grew a potato and sold it, and a farmer grew a potato and sold it. If the potatoes were identical, they would have the same price and the same quality. So this should not be surprising to anybody. Okay. And then the quantity supplied, quantity demanded, quantity supplied, and the quantity demanded are all identical. Because we're at the equilibrium, at this price, at the equilibrium price, the quantity supplied is equal to the quantity demanded. If the price was 800, then the quantity supplied would be about 400, and the quantity demanded would be about 800. The quantity demanded will not equal the quantity supplied. If the price were 1,000, the quantity demanded would be down here about 50, and the quantity supplied would be up here at 1150. So the quantity supplied and quantity demanded don't equal. But at the equilibrium, quantity demanded and quantity supplied are equal. So we can say there is no excess demand or supply. Okay. Now these are $1,000 discount bonds, whether they're corporate or treasury. So the face value is $1,000. They are zero coupon bonds. Discount bonds are zero coupon bonds, so the coupon payment is 0. And the number of periods is 1. And we got to get the rate, correct? We need the interest rate. So we're going to use the rate equation. With the number of periods equal 1, the payment equal to 0, the price has to be negative because we're going to pay it. We're going to pay this price for the right to get $1,000 in the future from the issuer. So the interest rate or yield to maturity is 17.436. And again, it's identical for both. It's identical, right? They have the same interest rate. We'll hit enter to see if we get everything correct. And we do. Okay, now, because the United States has never defaulted on treasury securities, but corporations have, holding all the factors equal, default risk decreases the demand for corporate bonds, while the lack of default risk increases the demand for treasury bonds. So what that does is it increases the demand for treasuries and decreases the demand for corporate bonds, holding everything else constant, which is why the supply curves are held constant. Okay? So this is our treasury bond. And I think what I'll do is I'll do one at a time. Okay? So this is we're going to do the treasury first. Okay? So notice the price is bid up because people want that sense of safety. They know that these treasury bonds will not be defaulted on. So they're willing to pay a little bit of a higher price. Right? So how many people have left this market? Let's find out. Okay, so we end up with a price of 870.37. And what I'll do is I'll copy this down here and turn it red. And then I'll change the price. It got bid up a little bit, right? By people wanting that safety. The quantity increased as well. Because people are leaving the corporate bond market. They're leaving the corporate bond market for the treasury market. The face value hasn't changed. The coupon rate is still 0. The number of periods is still 1. And the rate is 14.93. 14.893. And these are treasuries. So I put in here treasury with default risk. With default risk. Okay. So about 70, if each person buys one treasury bond, about 70 new people entered this market to get that security, that assurance that the bond won't default. Okay, so let's go back to my open math. Okay, at the treasury bonds default risk adjusted equilibrium, the price is now a little higher. The interest rate, again, we use the rate equation from Excel. The interest rate is 14.893%, and the quantity of bonds is about 70 higher than it was. Okay. Now let me freeze this pane here. View, freeze pane. Okay. I'm going to copy this. I'm going to do it for the corporate bonds. Now I got to copy the corporate bond equation. I'm going to replace the treasury. Okay, so people have left the market, right? The people that left the market entered the treasury market. However, not everybody leaves because the price gets bid down to here. Maybe this is the price at 832.679, where people are like, all right, I can handle that much risk in the corporates, right? So not everybody's going to leave, right? The price got bid down, and the people that left this market entered the treasury market. So let's click on the dot right there and then fill in this information. The price of the corporates dropped to 832, and it dropped just enough to keep some in the market. And then the quantity in this market is 535.849. And the rate went up to, plug in that information, the rate went up to 20.94%. So let's grab the price. So the price got bid down a little bit. That resulted in a higher yield maturity. Higher interest rate, and fewer people left, right? People left this market, right? Okay, now let's go ahead and label it. Okay, so we got the price. These are treasury bonds. These are corporate bonds. Price. Quantity. We have the supply. Demand. And then the original equilibrium. Both at around 600. The original price about 850. for both. Okay. But then we introduce risk and we get the demand curve with corporate default risk. Okay, I'll just call that right there. And the quantity increased, right? The quantity increased for treasury bonds, and the price got bid up too, right? People were willing to pay a little higher price for that safety, that increased safety. Corporate bonds, people got spooked and left the market, which pushed the price down until people were okay with the level of risk that is inherent with corporate bonds. So the price got pushed down a little bit. And that's how you label that diagram. So go ahead and close this out. Now the default risk premium is just the difference. The default risk premium is the difference in the two interest rates. And it looks like the default risk premium here is 5.202%. So it's the difference between these two interest rates. Okay? Now we got this little bit of a problem down here. We're going to kind of expand on this idea. So you own a $1,000 9% General Motors bond that matures in 1 year. Now, I don't know if you remember this, but the Obama administration during the financial crisis kind of changed the bankruptcy law when it stripped the primary bondholders of their first claim rights on corporate assets during the General Motors bailout. So we want to explain why corporate bond prices would be lower in the post-bailout era, holding everything else constant. Then doing this, assume the GM bond sold for $10.58 before the bailout, but sells for $10.39 after. Okay, so we gotta calculate the rates, right? So let's go down here. Let me unfreeze the window. We'll go down here. Okay, so we have the face value of $1,000. We have the coupon rate of 9%. And the number of periods is 1. It matures in 1 year. This could be a 10-year bond that you bought after the 9th year. Or it could be a 1-year bond that you bought when it was issued by General Motors. Okay. And then what else do we have? We have the price, the present value. The price is $10.58. Whoop. This is before, and this is after. And we need the rate, right? Okay, so let's figure it out. Let's type in rate. Number of periods is 1. The payment, I haven't calculated yet, but I can do it right here. 9% of $1,000. And then the price, we got to make that negative because we got to pay the price, $10.58, in order to get that coupon and that face value. We get entered, we get 3%. $3.02%. So the bond yield before the bailout was 3.02%. Let me increase to 3 decimal places in case. Okay. What is the bond yield after the bailout? Well, the face value is still $1,000. The coupon is 9%. 1 period. And the price after the bailout, it dropped to 1039. And then we type equal rate. Number of periods is 1. Now the payment is, the coupon payment is $90, right? 9% of 1,000 is $90. And then the price enters as a negative because we got to pay that price. And then the face value is 1,000. So the yield went to 4.909%. So the yield after the bailout is 4.909%. So the default risk premium is just a difference in the two. So the default risk premium is just a difference in the two. And we hit enter. And maybe this needs to be 3. Okay, what happened here? So let's try 2 decimal places over here. Instead of doing it in our head, let's shrink it. Oh, there we go, 3.02%. Why is that? So, okay, so this is a 4. So when we round it to 2 decimal places, that's a 4, so that stays at 2. Excel can be sometimes misleading. If you round that correctly, if that was the number, you'd round it to 3.03. But it's actually 3.0246, so it actually rounds to 3.02. So let's try that and see if it works. Yep, that works. Okay, which is odd because sometimes MyOpenMath can do math and sometimes it can't, and it has trouble sometimes rounding. Okay, we'll just do 2 decimal places. Okay, now according to the figure below, default risk premium in a given year equals the vertical distance between the red graph. The red graph is the corporate AAA bond, and the reason why I say the corporate AAA bond, because corporate bonds are not as liquid as treasury bonds. So I like to think of the difference between the government bonds and the corporate AAA bonds as being really due to the size of the market. The corporate bond market is much smaller than the treasury bond market. And the size of the market, the number of buyers, kind of determines how liquid a market is. So you could say the long-term government bonds are more liquid than corporate bonds in general. So I like to think of the difference in these two trends as the illiquidity premium. And the reason why I say that is because corporate AAA bonds are pretty close to being risk-free. I mean, they're very they have a high rating. So the default risk between these two is kind of small. So I think most of this difference is due to the size of the treasury market relative to the corporate market, which means this difference to me is more about liquidity than default risk. But corporate BAA bonds, on the other hand, the difference between those yields and the corporate AAA bonds can be really dramatic. And I think that's because of default risk. So I like to think of the default risk as the difference between the corporate AAA bonds and the corporate BAA bonds. All right, so we're going to say the blue graph. And that is correct. The default risk premium reached a historical high when it reached its height. Well, back here, right? Notice that corporate the difference between the red and the dark green lines pretty stable even during the Great Depression, right? Kind of inverted in the 1940s, which is interesting, right? But look at this huge difference here. That's probably about 1932. And then the default risk premium probably reached a historical low in 1946. Yeah, it looks like 1946. The government the difference between the red and blue almost touch each other in 1946. Also, probably here and here. But we'll call it 1946. And we're done with default risk premium.